Let's talk about every electrician's weekly headache. You open up a panel. It's a 100-amp panel. You've got central AC, an electric water heater, an electric dryer, plus your small appliance circuits. Your load calculation is already sitting at about 110 amps before you even start doing any real work. And now, the customer wants level 2 EV charging, 48 amps on a 60-amp circuit.
You run the math, right? You add that EV charger to the load calc, and suddenly you are looking at 170 amps on a 100-amp panel. There is no way around it. That fails code. It fails inspection. It's just over before it even begins.
So what do? How do you actually install a 48-amp charger on a full 100-amp panel without an upgrade? Because the second a customer hears they need an $8, $10, or maybe even $15,000 utility service upgrade, the job dies right there. They get massive sticker shock and just walk away. But I'm going to show you the exact fully code-compliant fix to save this job. I actually just did this in my own house, passed inspection, with absolutely zero panel upgrade.
Normally, you're stuck with three pretty terrible options. Option 1, you downgrade them to 20 or 30 amp charging, and they're unhappy because it's just not the speed they wanted. Option 2, you quote that massive service upgrade, pulling permits, coordinating with the utility, cutting power to the house for a whole day. Or option 3, the job just doesn't happen. You lose the lead, the customer goes back to a standard wall outlet, and nobody wins here.
But there is a fourth option that completely changes the math. It's called an EV Energy Management System, or EVEMS, and honestly, it's a total game changer. It uses specific national code exceptions. We're talking NEC 220.70 and 625.42 subsection A. These codes let you use a smart load management device to legally omit the EV charger's maximum potential power from your load calculation. You are not bypassing code. You are safely working right within it.
Think of it like a smart traffic cop for the home's power. It sits right between the main panel and the charger, continuously monitoring the total electrical load in real time. If the house is pulling a ton of power, say the AC and the dryer are both running, the system safely throttles the EV charging speed down. But when the house is quiet at night, it cranks that EV charger right back up to full speed.
And the hardware doing this heavy lifting is surprisingly compact. You've got units like the ChargeXcel 60 and its precise CT, or current transformer clamps. These little clamps just wrap right around the main power lines to measure the current. That tiny black box is what handles all the real-time monitoring. It literally fits inside a standard junction box right next to the panel.
For us licensed electricians, the install is an absolute breeze. It's basically 3 quick steps. First, clamp those 2 CTs around the main L1 and L2 service lines inside the breaker box. Second, wire the L1, L2, and earth connections. And notice there is no neutral wire needed, which keeps things super clean. Finally, just mount the unit inside a standard polycarbonate NEMA 4 box near the panel. No utility delays, no ripping walls apart.
The configuration is just as elegant. You set the whole thing up right from your phone via a local Wi-Fi portal. If you've ever been sweating in a dark garage trying to flip tiny dip switches with a flashlight in your mouth, you are going to love this. No dip switches, no proprietary data cables to fish through the drywall, and absolutely no mandatory cloud subscriptions. It is local, fast, and incredibly simple.
Now keep in mind, these devices generally fall into 2 camps. On one hand, you have hard load shedding, like DCC or black box. These completely cut power to the charger when the panel hits 80% capacity and just turn it back on later. On the other hand, you have dynamic load balancing, used by systems like ChargeXcel, Wallbox, and Emporia. These intelligently dial the charging speeds up and down, squeezing every possible amp out of that panel for maximum efficiency.
Obviously, your license and reputation are on the line, so safety is a massive priority. You don't have to worry about inspection failures with these top-tier systems. They have 2 layers of protection, the smart software throttling, plus a physical hardware fail-safe relay that instantly cuts power during an overload. If the home's Wi-Fi drops, the system just operates locally. Plus, they carry strict UL 916 certifications, meaning city inspectors absolutely love them.
You can actually see the CSA and FCC certifications stamped directly onto the hardware. So when the local building inspector shows up, you literally just point to the label, hand in the spec sheet proving it's an approved energy management system, and you get your green tag without any hassle.
Let's look at the real numbers because the business case here is wild. A full service upgrade, that's 1 to 2 days of labor, coordination, and killing power to the house, running the customer anywhere from 8 to 25 grand. Your win rate on those quotes is going to be pretty low. But an EVM's install, 1 to 2 hours, the total cost drops to between 2 and 5 grand. When you offer an affordable, elegant solution like that, your job win rate absolutely skyrockets. It really comes down to this.
You are turning a $20,000 headache into a huge opportunity. Customers say yes so much faster, and you actually keep the job. By bringing EVM's technology to the table, you're saving the homeowner a fortune while establishing yourself as the forward-thinking EV expert in your area. You're the one bringing solutions, not expensive ultimatums.
So here's my question for you. The next time you're standing in a garage, staring at a fully loaded 100-amp panel, and that load calc comes up way over the limit, what's your move? Are you going to walk away from a lost lead, or are you going to use an EV-EMS to safely and legally turn that dead end into a very profitable win? The tech is here, the code supports it, so the choice is yours. Thanks for checking out this explainer, and I'll catch you on the next one.